Okay, let's take a look at an exercise involving center of mass of this bar with these two balls on it. Um, and it says here to calculate the center of mass two ways. So one way in part A, we'll place the origin at the left end of the bar, something like this. So x and y here. This is part A. And then part B, we'll just place the origin down here. And I'll just use the same direction for the coordinate system just as a matter of convenience. So this is what we'll do. So for part A, we just need to write out all these masses and their centers of mass. So this ball here, this 8 kilograms, is considered to be a point mass, and so its center is right at its center there. The same thing with the 7.5 kilograms, and this 9 kilogram bar. It says that it's a uniform 9 kilogram plastic beam, 3 meters long, and so because it's uniform, or homogeneous is another way to say it, then all the material is evenly distributed, and so we have the center of its mass would be at its geometric center. And so we would have kind of the center of mass of this 9 kilograms would be right here at 1.5 meters. That's where this would be. And so to find our x center of mass, and now the y center of mass, assuming these are all infinitely thin, we weren't given like locations to the y center of mass here because we're assuming this is infinitely thin, so it's really just kind of in one direction, just in the x direction here. So the x center of mass is a weighted average, and we just take the mass of each object times the location of its center of mass, and then we sum them all up and divide by the total mass. So for the 8 kilograms, write it out here, we have 8 kilograms times its center of mass with a coordinate system over here on the left side. Its center of mass in the x direction is 0, right? Because it's right there on the y-axis, plus the 9 kilograms times the location of the center of mass of the 9 kilograms, which we said is at its geometric center, which is 1.5 meters from the left end, so 1.5 meters, plus the 7.5 kilograms times the location of the center of mass from the left. So that's going to be, it's 3 meters minus 60 centimeters minus 0.6 meters. So this is 2.4 meters. And we divide it by the total mass. So the total mass is 8 kilograms plus 9 kilograms plus 7.5 kilograms. Now it's really important. I think that the most common mistake I see is that people will say, oh, well, this is located at 0, so I don't have to include it. But you do have to include it. It's very important. It sort of makes the center of mass of the whole thing closer to 0. If this were like 8,000 kilograms, then we would expect its center of mass is essentially right here where this one is, because this and this are very, very small compared to this, right? So it definitely, every mass has to be added in there. So make sure to include the 8 kilograms on the bottom. And it's just a good habit to include it on the top. That way you don't forget about it on the bottom. And so what we end up with here is that the x center of mass, once you do all these calculations, this comes out to be 1.286. And the units here, this is kilogram meters on the top divided by kilograms on the bottom, and we have, this is just meters, right? So 1.286 meters, which, the center of mass is a location, so it should have units of length. And then in part B, we have, or actually, it's really, the center mass is a ordered pair, so I guess really in 2 dimensions this should be 1.286 comma 0 meters, right? This is the center of mass. But it just asks for the X center of mass. So you could have just left it this way. For part B, like I said, we're coming up here and we're going to have the coordinate system over this way. I'm going to call still positive to the right. So actually, by calling positive to the right, this will have a negative location, right? Actually, all of them will have negative locations. So let's write that out here. So for part B, we have our X center of mass is going to, I'll just go ahead and start from the left, or sorry, from the right and work left. So 7.5 kilograms times its location based on this new coordinate system. This is negative 0.6, negative 60 centimeters. Plus 9 kilograms is the next one. So 9 kilograms times its location is going to be, well, it's still in the center, so it's negative 1.5 meters over here. It's going from the right to the left. So times negative 1.5 meters plus 8 kilograms, and this is located at negative 3 meters, right, all the way at the other end. So 8 kilograms at negative 3 meters divided by our total mass again. So that was 8. Well, let's just go ahead and put the sum, 24.5 kilograms. This is exactly the same as it was before. And so the X center of mass now is negative 1.714 meters. And then for part C, it asks us, is this the same? Do you get the same result both ways? So in part B, negative 1.714. Part A, it's 1.286. Is this the same? They're not the same numbers, but it is actually the same location. If I move 1.286 meters from the left towards the right, it puts me about right here, which is the same as if I move 1.714 meters from the right to the left. I get the same position either way. So the answer is actually yes, you do get the same result both ways. You don't get the same number, but you're using different coordinate systems. So the important thing here is to note that the center of mass is based on a coordinate system which is chosen here. So in order to find the center of mass, you have to first define the coordinate system, otherwise it's meaningless.